In this segment, we're going to finish up our discussion of pre-training by talking about a couple additional recent models that are useful and kind of contrast with what we saw before. So the first of these we're going to talk about is BART, which was released by a team at Facebook, Lewis et al. In late 2019. And this is a sort of version of BERT, let's say, that is a sequence-to-sequence model. So what they did is they, rather than taking a masked context here, which we see as, which would be something like A, B, C, D, E, and then mask out one or two tokens and then predict them from the context. Instead, what they do is they have a setup that looks more like a denoising autoencoder. So they take as input over here A, B, and E with a couple of other blanks, and then they want to actually predict with this decoder A, B, C, D, E. And so this is different than the BERT model, but it kind of combines the strengths of both GPT and BERT in some sense, and because the encoder can look at everything in a kind of bidirectional fashion. The encoder is basically like BERT, and then the decoder is going to go along and generate things token by token like a language model like GPT. And so the decoder can also look at everything in the encoder context, so it can look at all of A, B, E. You don't have this issue where it has to forget that it has seen stuff, but it doesn't cheat in the way that we talked about back when we originally discussed BERT. So essentially, this is a way of pre-training a sequence-to-sequence model, and the nice thing about this is it lets you learn a model that should be good at certain types of copy operations, for example. So the results they had on the glue tasks were not really better than Roberta. But what the big selling point of this was results on dialogue and particularly summarization. Because of the way they do this, they set up their pre-training where you see a sort of noisy version of the input and then you try to unscramble it and assemble it into coherent language. That sort of looks like, you see a summary or you see a big document with a bunch of extra information in it and you want to grab pieces of it out and stitch those together into a summary. So it's nicely targeted towards tasks that look like that, and we'll discuss it more when we talk about summarization later. But this is emblematic of a trend in pre-training, which is sort of coming up with bespoke pre-training methods that are well tailored to certain tasks. So there are other methods that are also fit to things like summarization, either single document or multi-document or translation or things like that. So a competitor released around the same time was a so-called text-to-text transformer framework from Google, from Rafael et al. And this kind of has some of the same motivation as all these other models in that we want to frame everything as kind of sequence-to-sequence tasks. And so what they show here is having a bunch of different tasks formatted in the sequence-to-sequence fashion. And they're training with this, they trained with a denoising scheme very similar to what BART used. So these came out around the same time and kind of reflected independent, coming to some of the same ideas. And I'm not going to go through all the results on this either. They had a very large corpus of text, and one of the interesting results they showed was that we still haven't really hit the limit of bigger and bigger data. Well, this was before GPT-3, so it's a little bit hard to know, but at least at the time what they were arguing was that kind of seeing more unique data here with the full data set on top here compared to subsets of the tokens below that gave better performance. And so it was still the case that scaling up with bigger models, bigger compute, bigger data was a path to building better systems. So this rounds out our discussion of pre-training. And so there's a whole universe of techniques out there. This is really just a slice of them. It's not updated to include a lot of these latest ones. There's a whole section that we haven't discussed that deal with things like cross-modal representations, like visual kind of that can deal with visual features as well as linguistic ones. There's a whole set of models that deal with entities. So they try to make they try to inform things, inform representations of entities from knowledge bases like Wikipedia. And so there's just a massive amount of stuff out there, and I think it remains to be seen which of these techniques comes out on top, how it all fits together, whether we're going to need different techniques for different tasks, etc. So this kind of leaves us with an open question that the field is still very much working on, of what the future is going to look like, and it'll be exciting to see, but we don't really know yet. That's the end of this segment.